Welcome back to Math Dogs. If you're new to the channel, please comment, like, and subscribe. If you have any questions, please comment down below. Problem number 89 is logarithmic and exponential forms. It says write in exponent form log base 2 of 16 equals 4. So when you listen to the log base 2 of 16 equals 4, you hear the word base with the 2. That's going to form the base of the exponential form. I'm going to take the base 2 and I'm going to raise it to the 4th power, and that will be equal to 16. And so the log form, log base 2 of 16 equals 4, in exponential form would be written 2 to the 4th equals 16. Problem number 90 is again logarithmic and exponential forms. This time it says to write in logarithmic form the exponential form 5 to the 3rd equals 125. So again I'm going to start with my base. I would have log base 5, and I'm going to follow the same process. Base 5 of 125 equals 3. So the exponential form base 5 to the 3rd equals 125 would be log base 5 of 125 equals 3. Problem number 91 is the log properties. It says to write in expanded form log base 3 of x to the 4th over y to the 5th. So if you remember from the exponent rules, to divide exponents, we subtracted. And so we're going to do the same thing with logs. To write this in expanded form, we're going to write log base 3 of x to the 4th, and to show the division, we're going to subtract another log base 3 of y to the 5th. So in expanded form, it would say log base 3 of x to the 4th minus log base 3 of y to the 5th. Problem number 92 is again log properties. This time it says to write in condensed form 2 log base 5 of x plus log base 5 of 7. So I have two things happening in this problem. I have a 2 out front, and since this is multiplication, it's going to indicate that the x is being squared. So I would have log base 5 of x squared plus log base 5 of 7. The plus sign, or the adding of the two logs, indicates that the arguments are being multiplied, very similar to the exponent rules. So in condensed form, this would say log base 5, x squared times 7 is 7x squared. So I would have log base 5 of 7x squared. Problem number 93 is solving log equations. It says log base 2 of x plus 1 minus log base 2 of x minus 4 equals 3. So the first thing I'm going to have to do is condense the left side into a single log so that I can use my definition to set up an equation. So since this is subtraction, remember the two arguments are therefore being divided. So I would have log base 2 of x plus 1 over x minus 4 equals 3. Now that I have it condensed into a single log, I can apply the log definition. Base 2 raised to the 3rd power will equal the argument. So 2 raised to the 3rd power will equal x plus 1 over x minus 4. 2 to the 3rd is 8, so 8 equals x plus 1 over x minus 4. To help me out, if I want to put 8 over 1 so that I have my two fractions, I can then multiply both sides by x minus 4 to remove the denominator. So 8 times x minus 4 will be 8x minus 32. On the right side, x minus 4 divides out with x minus 4, leaving me with 1 times x plus 1. Now I have a basic equation. I'm going to subtract x from both sides. 8x minus 1x is 7x minus 32 equals x minus x is 0 plus 1 is 1. And here I'm back to a two-step. I'm going to add 32 to both sides. Negative 32 plus 32 is 0. 0 plus 7x is 7x equals 1 plus 32 is 33. And my last step would be to divide both sides by 7. So x would equal 33 over 7. Problem number 94 is solving log equations. It says log base 5 of x plus log base 5 of 4 equals 3 log base 5 of 2. So the first thing I'm going to have to do is condense the logs on the left side and condense the logs on the right side. Since this is addition of logs, my two arguments x and 4 are being multiplied. So the left side would condense to log base 5, x times 4 is 4x. On the right side, since I have a 3 out front and these are being multiplied, remember that indicates an exponent. So this would be log base 5 of 2 to the third. Now, since both of these say log base 5 equals log base 5, it indicates my argument 4x must be equal to the other argument 2 to the third. That's the only way those two could be equal. And so my equation would just say 4x equals 2 to the third is 8. Now I just have to divide both sides by 4. 4 divided by 4 is 1x, and I would find out that x equals 2. Problem number 95 is the change of base formula. It says log base 3 of 22. So the change of base formula says that I can change the base of the log by writing a ratio. So if I have log of a base a to n, that's equal to log whatever I would want to change the base to. I'm not going to write a base because that would indicate base 10 of n divided by log of a. Notice the base goes on the bottom and the argument goes on the top. So when I don't write a base, if I just write log, it indicates base 10, what's called common log. And so in my formula, log base 3 of 22, I can write with the common log. Common log 22 is going to go on the top part of the ratio. Common log, the base 3, will go on the bottom part of the ratio. And then I could simply punch that into a calculator. Common log 22 divided by common log of 3, if I round that off, is about 2.8136.